So this lesson is about solving inequalities in set notation. So if you're in Algebra 2, what you're going to be doing is starting with this right after you do graphs of functions. So this is in the first unit that we do. And really, it should be something that you have covered in Algebra 1. So it should be a pretty good refresher with working with inequalities. And the thing that we're trying to build you up to is learning domain and range. Okay, so specifically set notation and interval notation. So maybe this should say interval. So I'm going to change that. You're going to learn some interval notation. Interval notation is a great way, once you kind of understand it, to talk about graphs of functions, their domains, and their ranges. And so whenever you're practicing with interval notation with inequalities, it kind of comes into practice whenever you're working on those. So the first thing we want to talk about is the types of graphs that you're going to see with these inequalities. So let's talk about graphing these inequalities just kind of as a precursor. So with these graphing inequalities, you want to use a closed dot for greater than or equal to and less than or equal to, or less than or equal to symbols, okay? Whenever you're graphing these, and you'll kind of see what I mean here in a minute. So if this doesn't make any sense, I would just write it down and then head to your problem. And once you have this written down, it's going to make a lot more sense. So I'll probably refer back to it. And then you want to use an open dot for greater than symbols or less than symbols. So that's what I wanted to say, and I want to make kind of just a brief statement about how to distinguish between greater than and less than, because I get this a lot in class. So one thing that I would say is that anytime you're reading or looking at a math problem, you should read it like a sentence in your head. Try to read it like a sentence, okay? So when I'm reading this statement from left to right, let's say I have this statement here. When I read it from left to right, I start with the x, and then I put in words what that symbol means, okay? And so this symbol means, it says x is greater than 7, okay? So the greater than goes right there, okay? And so here's another one. X is less than or equal to 8. So let's try this one. So x is less than or equal to 8. And so there's two types of symbols here. You've got a bar at the bottom, which means the value can be equal to the number that's given. So if you don't have a line at the bottom of your greater than or less than sign, that means x is strictly greater than 7. It cannot be 7. But in this case, over here it says x is less than or equal to 8, then x can be 8, and then any number less than 8. So we'll kind of talk about what that means. But one thing I want to get out of the way right now is how to distinguish between the two of them. And this is something that I would write down. If I have a symbol, it's either less than or greater than, and maybe I'm getting confused on this. So if you are getting confused on this, see if you can make a g out of it. If you can take this point and make a g out of it, then it's greater than, okay? So that's how you would read that symbol. So greater than. So maybe you're just struggling to see what that symbol is. This is a greater than symbol. So anytime I see that arrow pointing to the right, I can make a G out of it. This arrow is what I like to call it sometimes so students can see that it's pointing to the right. I can make a G out of this, and so this is greater than. If I do not see this and I instead see this, we'll see if you can make an L out of it. So if you can write in ESS and then you can make less than. So that object, that symbol there is less than. So hopefully that helps you out, but we are going to talk about some more notes before we get into some examples. So the thing I want to talk about is interval notation. And so interval notation is a way to write the solutions, all the solutions, so there's infinitely many normally, the solutions to an inequality. Using infinity symbols, parentheses, and brackets. So parentheses indicate that a number is not included. Or the set is open. And we'll talk about what that means. And then brackets indicate that a number is included. Or that the set, the interval notation, the interval is closed. Okay, so the set is closed. So I would definitely write these things down. Okay, so if you haven't gotten those written down, I'll give you a second. I do need to grab my coffee. And so hopefully that gave you a second, but you can always pause the video. So I'm going to go ahead and move on and we'll get to our first example. Okay, so we're not only going to graph this function, not this function, we're going to graph this inequality, but we're also going to look at the set, okay? And we're going to tell if it's open, closed, that kind of thing, and we'll tell which kind of bracket we use. So I have x, that symbol, and then 8. And so I take a look at this and I say to myself, okay, what does this symbol mean? Well, I can make a G out of that symbol. That arrow is pointing to the right, so if I make a G out of that, that means x is greater than or equal to 8. So if that's the case, if x is greater than or equal to 8, that means x is, so I'm going to write this in words, x is greater than or equal to 8. So in this case, right, what are numbers that are greater than 8? Well, to kind of visualize that, what I'm going to do is I'm going to draw this number line. And so I've got, right, 0 is here, 1, 2, 3, 4, 5, 6, 7, 8. And so now I decide where 8 is on this number line, and we know exactly where it is. It's right here. And then we ask ourselves, okay, can I plug in 8 in for x and have this be a true statement? So if I take a look, it says x is greater than or equal to 8. Well, anytime it says greater than or equal to, it means it can be the number. So this means that I'm going to put a solid dot. Anytime I have an equal sign, that bar at the bottom of my inequality, then I can have the number. I can include the number, so I'm going to use a solid dot. And then I'm going to shade numbers. I'm going to shade towards the direction where there's numbers that are greater than 8. So if I take a look at this number line, 7, 6, 5, all the way down to 0 and beyond, these numbers are less than 8. So I want to shade towards numbers that are greater than 8. And so any number that is greater than 8 will work. And so we want to write that in interval notation. So that's the next thing we're going to do. So interval notation for this guy. Interval notation would be bracket, because it's included. So I can have the number 8. So if I have a solid dot, that number is included. I can be 8, and I can be any number larger than 8. So any number larger than 8, this goes all the way to infinity. Okay, so because this red arrow points to infinity, my interval would be any number from 8 to infinity. So if you can think of a number from 8 to infinity, like 7,000, that would be greater than or equal to 8. So it would be a solution to this inequality. So that's kind of what we're getting at. So we're going to try another one. So hopefully you did okay with that one. But if you didn't, here's some extra practice. Let's have a is less than -1. So even though this is a different variable, we're going to graph it on the same type of number line. It is a quantity, and we want to see what a can be, what numbers that a can take on. Okay, so the first thing I'm going to do is I'm going to take a look at this symbol, and I realize that I can make an L out of it. So this is less than. So since it's less than, what I can do is I can write a sentence for it. So a is, excuse me, didn't mean to write that. A is less than -1. So if a is less than -1, that means it's lower values than that. So we're going to draw our number line, and we're going to see if we can write this out. And the reason why I don't have an equal to symbol here, I didn't say it's less than or equal to. If you take a look at a and the less than symbol, there's no bar at the bottom. So a cannot be equal to -1. It can only be less than -1. So that's going to come into play here in a second. So I've got 0, 1, 2, 3, 4, -1, -2, -3, -4. So you choose your scaling for this. You want to choose a number close to what you're using. You can count by a different scale, but we'll get to that here in a minute. Really what you want to do is just make sure your number is on that number line, and it's probably good to know where 0 is. But in this case, -1 is the number in question. So notice that I have a is less than -1. So -1 is the number I'm going to start with, and it cannot be included. So unlike the last example, because of the equal sign, we put a solid dot. For this one, because there is no solid line at the bottom, it cannot be equal to. So instead of a solid line, we're going to use an open dot, is what that means. So if you look back in your notes, hopefully you wrote this stuff down, but an open dot is used for greater than signs or less than signs. And then I'm going to shade towards numbers that are less than -1. So numbers that are less than -1, that are lower in value, are this direction. And so whenever I'm creating the interval notation, I'm going to read this arrow that I've drawn from left to right. So before, the number, whenever I was reading this graph here, I pick it up at 8. And then any number that's larger than 8 is to the right. So this interval would be 8 to infinity. So a great way to do this is to put your marks in for what symbol you're going to use. So since this is open, I'm not going to use a hard bracket like I did here, a bracket. I'm going to use parentheses. So I'm going to end parentheses here. And then I'm going to think about where infinity is. So infinity is this direction, but it's not included. Negative infinity is in this direction. So if I'm reading from left to right, I'm coming from negative infinity. So my interval notation would be negative infinity to that number that I'm trying to stop at. So from negative infinity all the way to -1 is where I'm going to stop. So end parentheses. And anytime you're dealing with negative infinity or positive infinity, I should mention this, you're going to have parentheses. And the reason is because we use parentheses to indicate something that's not included. And so if I think about infinity as a concept, there's no way that I can get to infinity in mathematics. It's only something that I can approach. So whenever I'm talking about that, any number from negative infinity to negative 1 works, but there's always a lesser number. There's always a number that I can go past. So if I go to a negative a billion, there's always a negative a billion and 1, or a negative a billion and 2. You can always get closer to negative infinity, but you can never reach it. So we use parentheses to indicate anytime we're near infinity or negative infinity. So that's what I wanted to say about that. So I think that's good. And then we'll do a few more notes. So here we go. Next set of notes is we want to follow the same rules to solve an inequality as you would an equation. So whenever you see an inequality and you see other terms with it, like a coefficient, a number in front of the variable, or something subtracted from the back of it, you want to go through the process of solving that equation, okay? So you want to isolate the variable term, and if the variable term is on both sides of the inequality, what you'll see is you want to group those terms on only one side of that inequality. That's one thing I want to say. And then the next thing that I wanted to say is you want to make sure that if you divide or multiply an inequality by a negative, the inequality, so if you divide the or multiply an inequality by a negative, then the inequality must flip. And this is confusing at first, but here's the reason why. So I'm going to give the reason, and if it doesn't make any sense, just try and take it as truth, okay? So if I have a negative x is less than or equal to 5, there's a way that I can solve this. And I could multiply both sides by -1 and flip. So that's what it's saying. But the reason why it flips is because if I add x to the right-hand side of the equation and I do not move the inequality, then what happens is I get 0 is less than or equal to x plus 5. And if I solve for x now, I get that -5 is less than or equal to x if I subtract 5 from both sides of that inequality. So that's what I did there. So here I got x, -5 is less than or equal to x, which is the same as x is greater than or equal to -5. Okay? So that's the reason why it flips. So if you take a look here, these two statements are identical, other than the fact that there's a negative that moved to the other side, and then the inequality flipped directions. And the reason is because whenever you add a value to the other side of the inequality, it crosses that boundary, and it flips that inequality whenever you add and then subtract something. So the other way to solve this they're talking about would be to just take the negative in front of this x, divide both sides by -1, and then flip the inequality, and you'll get the same result. So that's the fast way to do it. The way that I just showed you is explaining why the inequality flips, okay? So now we're going to get into some practice examples. So the first one that they give us is 5v plus 1 is greater than 7v minus 17. Okay, so what I want to do is solve for v. So I'm going to solve this like an equation, but I'm going to treat this operator, this greater than sign, like an equal sign. So if I subtract 1 from this side, I'm going to have to subtract 1 from the other side. So I'll just highlight this so you can see where the boundary is. So if I subtract 1 from over there, I'm going to subtract 1 from the other side of that inequality. So I've got 5v is greater than 7v minus 18. And so now I want to group the 7v and the 5v, but they're on opposite sides of that inequality. So what I'm going to do is subtract 7v and subtract 7v from that side. So 7v on the right-hand side will cancel. On the left-hand side, 5 minus 7v would be negative 2v. So I'm left with negative 2v is greater than negative 18. And so right here, I have two options. I can either add 2v and then add 18, and then the inequality would be fixed, or I can divide both sides by negative 2, which I'm going to do. But I have to remember, right, just to refresh your memory, if you divide or multiply an inequality by a negative, which I just did, then the inequality must flip. So that's the first thing I'm going to do down here. So that inequality now flips, and he flips from greater than to less than, not greater than to greater than or equal to, or less greater than to less than or equal to. It does not add a bar. All it does is change the direction, okay? Changes the direction of your arrow, if you will. So I've got v is less than 9. So if I'm graphing this, right, I've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. So right, this side of the number line points to infinity. This side of the number line points to negative infinity. So if I mark 9, I'm going to mark it with an open dot, and that's because there is no solid line at the bottom of this statement. So we're finished here. We've solved this inequality. So I've got v is less than 9. And then I'm going to shade to numbers that are less than 9, because this statement says, right, I can make an L out of it, so v is less than 9. So numbers that are less than 9 are down here. They're all the way over there. And so now I can create my interval. So my interval notation, if I read from left to right, I'm coming from negative infinity, so this arrow points all the way to negative infinity. And I go all the way to positive 9. And since it's an open dot, it is not included, so I'm going to write parentheses. So, there we go. Let's do another one. And again, this is extra practice, and this is helpful for people that are trying to take notes, but I do suggest that if you're new to this and you want to learn, I would pause the video whenever you see the inequality first set up, try it out for yourself, and even if you get it wrong, look at the solution and see where you went wrong. So right here, I've got negative 3 in front of the parentheses, and what I did was distribute it, okay? So that's the first step. Whenever I distribute a negative, it flips the sign. So I've got negative 3 times 5 is negative 15, negative 3 times 9 is negative 27. So you can check your arithmetic there. And then I'm going to combine like terms on the left-hand side. So my like terms are the variable terms. So those are my like terms, but notice that this is a negative 15. So whenever you have a negative, you're subtracting the coefficients. So I've got 21 minus 15, which is going to be 6x, minus 27 is greater than or equal to 7. And then what I'm going to do is get rid of this negative 27 by adding. So I've got add 27 on that side and this side. So I've got 27 plus 7, which is going to be 34. So 6x is greater than or equal to 34. And remember, we're just treating this, I'll do this in a different color. We're treating this operator like it's an equal sign, okay? So all I did here was distribution and then combining like terms, but at this step, the adding 27, I do it on both sides of the operator, okay? And then down here, I want to get rid of the 6 in front of x, so I ask myself, okay, what's happening between 6 and x? Well, it's multiplication. So what undoes multiplication? Well, that's division. So if I divide both sides by 6, then I have x is greater than or equal to 34 divided by 6. So 34 divided by 6, I may not be familiar with fractions, but I can certainly reduce that fraction. To reduce a fraction, you divide the numerator and the denominator by a common number. So if you take a look here, 34 and 6 are both divisible by 2. So I get 17 over 3. I think that's correct. Yeah, that's correct. So I've got 17 over 3. And so now I need to graph 17 over 3. But if I'm unfamiliar with that, then what I'm going to use is the decimal approximation of 17 over 3, okay, to find out where it is on the number line. So we're going to do that together. So if I go to my graphing calculator, if you have a different calculator, it should work out just the same. There will be certain functions you'll need the graphing calculator for, but if you have a regular calculator, it should do the same thing. So what this is telling me is that 17 over 3 as a decimal is 5.6, okay? So 5.6 is about where you'd put it on that number line. So 0, 1, 2, 3, 4, 5, and then 6. And since, again, I'll go back to it. Since I have 5.6 is 17 over 3, then my value is going to be right about here, and it's going to be a solid dot. And the reason why it's a solid dot is because there's an equal to sign at the very bottom. So that means that the number is included. So x can be equal to 17 over 3. And then the next thing I'm going to realize is which way I'm going to shade. So if you take a look at the greater than or equal to symbol, right? I did just give it away, but I can make a g out of it. So if I can make a g out of it, that means it's greater than. So I'm looking for values that are greater than 5.6 repeating, which are that direction. So now I'm going to read this from left to right. So if I look over here, there's no red, so I'm not going to pick up any of those numbers. So the first number I'm going to pick up whenever I'm looking at interval notation is this 5.6. And even though we just looked at the decimal approximation, you're actually going to leave it as a fraction, okay? So if I go back in here, in this bracket, I'm going to put 17 over 3 as my decimal, as my first value. And it does have a closed bracket. So this is a closed bracket, not a parentheses, because it has an equal to symbol at the bottom. So if it has an equal to symbol, you get a solid dot and a bracket. If it has no equal to sign at the bottom, then it has an open dot and an open parentheses. And then if I take a look at this, the arrow is pointing to the right and it's going on forever, so it will go all the way to positive infinity. And that is it for that one. So we'll do another one. And again, please do pause the video if you want to try it out for yourself to see if you can get it, and then we'll go over it. So, I'll let you think about that. So, hopefully you've tried it out. So we're going to go ahead and distribute this -2. So I have 12p plus 52 is greater than -8 plus 4p. So now what I'm going to try and do is I'm going to try and isolate this variable p, and then I'm going to try and get rid of this 52 over here. So what I'm going to do first is subtract 4p from both sides of this inequality. And remember that inequality acts like an equal sign. So I'm going to put that there so I know where to subtract from. So I subtract 4p from this side and from this side. Right? It's like a partition. So 12 minus 4p is going to be 8p plus 52 is greater than negative 8. And then I'm going to subtract 52 from both sides. And I get negative 60, or 8p is greater than negative 60. And then I'm going to divide both sides by 8. So I get p is greater than negative 60 over 8. So if I take a look at this, both top numbers, this is a fraction, and negative 60 is not evenly divisible by 8. So I can divide top and bottom by 4, so I can reduce that fraction. So 60 divided by 4, and then 8 divided by 4 is going to give p is greater than negative 15 over 2. And so notice that the inequality doesn't flip even though the right-hand side is negative. What I'm saying here, whenever I say to flip the inequality, is if you divide or multiply the inequality by a negative. Only if you yourself divide both sides by a negative or multiply both sides by a negative, that's when the inequality will flip directions. Because you get a negative value on one side, unless you divided by a negative 8 here, you would not flip the inequality. You just keep that number as a negative. So you can have negative solutions without flipping the inequality. The only time you flip the inequalities is if you divide or multiply by a negative. Okay? So I wanted to make that statement. And then negative 15 over 2, you can check with the calculator, and we'll do that. But I just wanted to make sure that you guys know that if you don't know that number is a fraction and you can't do that in your head, use a calculator. And so negative 15 divided by 2 is actually going to be negative 7.5. Okay? So if I want to know where that is on that number line, it's halfway between negative 7 and negative 8. So we're going to draw that out. And I'm going to count by 2's. So negative 2, negative 4, negative 6, and then negative 8. So negative 7 is halfway between there. So negative 7.5 is right there. And I'm going to shade towards numbers that are greater than negative 15 over 2. So first of all, that should be open. And the reason why it's open is because if you take a look here, negative 15 over 2, there's no equal sign at the bottom of the inequality. So it's just greater than, not greater than or equal to, and then I'm going to shade to the right. Okay? So p is greater than, right? Make a g out of that, roughly. And so now I'm going to give the interval notation. And so I read from left to right. Negative infinity is not included, so the first number I'm going to pick up is that negative 15 over 2. And it's going to be in parentheses. Negative 15 over 2, it's not included as an open circle, and that's because there's no equal sign at the bottom of this inequality. And then this arrow is pointing towards positive infinity, so these solutions will continue up until positive infinity. So if I take any value out of this list and plug it into this inequality, it will work. So I'm going to pick a value actually just to show you that's how that works. So I'm going to extend this graph out. Just continue to count by 2's. So 2, 4, 6, 8, 10. So if I continue this out, 10 is in the list. So if I substitute it in for p down here, I should get a true statement. So if I plug in 10, I get 10 is greater than negative 15 over 2. And if you take a look at that, you ask yourself, is 10 greater than negative 15 over 2? And so 10 is greater than a negative. So yes, 10 is greater than negative 7.5. That is a true statement. So true statement. So any number that you pick out of that list that arrow is kind of representing, any number in this list from negative 15 over 2 to positive infinity, it will make this statement true. The only numbers that won't work is negative 15 over 2 itself, because negative 15 over 2 is not greater than itself, and then any number less than that, okay? So let's do another one. 3 minus parentheses 4m plus 1 is greater than or equal to 5m minus 25. Okay, so this negative 1 will distribute to both terms. And so you're left with 3 minus 4m minus 1 is greater than or equal to 5m minus 25. So that's distributive property, so make sure that negative distributes to both terms. And then what we're going to do is collect all the m's. So if I subtract 5m from both sides of this inequality, I get 3 minus 9m, negative 4 minus 5 is negative 9, minus 1 is greater than or equal to negative 25. So now what I'm going to do is combine like terms on the left-hand side. So your like terms are your constant terms. Remember, numbers don't commute unless they have variables with them. So 3 minus 1 will be 2. So I've got 2 minus 9m is greater than negative 25. And then I'm going to get rid of this 2 because it's a like term with the negative 25 on the other side. So if I subtract 2 from here, I'm going to subtract 2 from the other side of that operator. And so I get negative 9m is greater than or equal to negative 27. And so now there's nothing stopping me from dividing both sides by negative 9 to get rid of that negative 9. But remember, there's a rule for this. Whenever you divide both sides by a negative, you need to flip the inequality. So I've got m is less than or equal to positive 3. And so now I'm going to graph that function. Not that function, but that interval. So 0, 1, 2, 3. I'll graph that interval. And with this inequality over here, I've got an equal to sign at the bottom. So that little bar tells me that it's going to be solid. And then if you take a look, the operator itself, I can make an L out of. So m is less than 3. So I'm going to draw towards numbers that are less than 3. So the numbers that are less than 3 are that direction. And then I'm going to read from left to right and construct the interval notation. So the interval notation should be, well, that arrow is pointing towards negative infinity, so if I'm reading from left to right, if I'm reading from left to right, all the way to the left is negative infinity. And then all the way to the right here, my ending point would be right here at positive 3. So close bracket. And so it's a pretty good start. And I think we're going to do one more example, and I'll call it a day. And I'm going to do a really hard one. So let's say I've got a really nasty one. 4 plus 5 times 2w minus 10 all over negative 2 is less than w plus 7. And I want to find the interval notation for this guy. So we're going to do that. So I encourage you to pause the video and then try it out on your own. So hopefully you've had a pretty good go at it. So what we're going to do is we're going to start with the numerator of this fraction. There's other ways you can tackle this. I just want to get this out of the way. So what I've got here is I've got 5 distributes. So I've got 4 plus 10w minus 50, and that's a minus sign in front of that 10, all over negative 2 is less than w plus 7. So if I take and divide each number by negative 2, what I'm going to get is 4 divided by negative 2 plus 10 divided by negative 2, and then I've got negative 50 divided by negative 2. So whenever I'm dividing a bunch of terms by a number, I can split that negative 2 into the denominator of each number. And so this has a w with it, so I forgot to carry that down. So it's going to be positive 10w here divided by negative 2 is less than w plus 7. So now what I'm going to try and do is divide these terms out and simplify this left-hand side. So 4 divided by negative 2 is negative 2. 10 divided by negative 2 is negative 5w. And then negative 50 divided by negative 2 is going to be positive. So negative divided by negative, don't forget, is a positive. 25 is less than w plus 7. So if you take a look at the left-hand side, negative 2 and positive 25 are like terms. So 25 plus a negative 2 or negative 2 plus 25 is going to be 23. So I've got negative 5w plus 23 is less than w plus 7. And then I'm going to solve for w. So first, subtract w from both sides of the equations, or the inequalities. I always say an equation because it just reminds me of solving equations, but it's not solving inequalities, very similar. Negative 5 minus w is negative 6w. Is less than 7. And so what I want to do now is move that 23 to the right-hand side of the equation. So I subtract 23 from both sides, and I get negative 6w is less than 7 minus 23. So 7 minus 23 negative 16. And then take and divide both sides by negative 6. And you're left with w is less than 16 over 6. And if you take a look here, 16 and 6 are both divisible by 2. So I can reduce this fraction. And I get w is less than 8 over 3. And so, again, I've got a nasty little fraction there. And if I'm not sure what that number is as a decimal, I'm going to type it into my calculator. So we're going to do that. 8 divided by 3 is 2.6. So that tells me where to mark it. So even though that was a longer problem, you should get the answer pretty well. If you can follow your order of operations of solving equations, then if you can solve a pretty complex equation, you can solve a pretty complex inequality. And so I've got 0, 1, 2, 3, 4, and so on. Okay, so I've got that. And so I want to mark 2.6, and I want to see if it's open or a closed dot. And in this case, since it's less than, right, less than, and there's no equal to sign at the bottom, I'm going to have an open dot at 2.6, roughly, so right about here. Open dot, and it says W is less than. But again, it's best practice to make sure that you always flip that sign. I had it as less than, but I forgot to flip it. And you'll probably see something similar. So just double check your work. I make mistakes. I'm a human being. But 16 divided by 2, and then negative divided by negative is positive, so still should be the same. So I've got 16 divided by 2 is 8/3, so it's actually greater than 8/3, which is this direction. So if I take a look at this, I'm going to mark that with an open parentheses, and then I'm going to continue all the way to positive infinity, right? That arrow is going toward positive infinity. So So positive infinity is over here. So I have to change my hands. So positive infinity is this direction. Negative infinity is this direction. So since it's pointing toward that direction, it's positive infinity. And then if you take a look, the open circle tells you that that number is not included, so you're going to have a parentheses around that number. So any number from 8/3, not inclusive. So any number greater than 8/3. So if I pick 2.7, that would be greater than 8/3. All the way to positive infinity would work. And that's all I wanted to say, so I'm going to upload this, so hopefully this helps.